All right, this is in the middle of chapter 5, we come across this type of integration where we're going to use division. So on the calendar, if you look where you found this note sheet link, there is a couple Khan Academy links to long division of polynomials and synthetic division if you prefer that. As a refresher for how to do those. So I'm going to walk through them with you today, but if you are still needing a little slower, different explanation, you can try there. So the unfortunate side of this topic is that it's good for like 1 point on the AP test. So there's going to be probably 1 question max for you to be able to do this. This just came about in the AB curriculum actually like 1 or 2 years ago. So this is the first time we're actually teaching it to you guys in this course in the event that you happen to see it, because I think it's popping up more and more. So in any case, what you can kind of see here in the purple is the issue. Like, we're going to be asked to do some integrals where the degree of x is going to be larger on the numerator than it is in the denominator, right? If you look at number 1, right? To this point, every time we did a u sub, we would let the denominator be u, and that's the only way we could work our u sub to figuring out this problem. Okay, but the truth is we want to be able to do it by division, right? And then that doesn't necessarily need a u sub with it. So what I'm going to actually do is be super weird and go to question 8. So I'm going to start us off on this one and then go from there. So let's look at this and verify that we need long division, right? The top degree is 2 and the bottom degree is 1. So no u sub is going to help you to do this. So instead what we're going to have to do is divide x minus 2 into 3x squared plus 5x plus 2. If you remember synthetic division, have at it. It's not my preference because I feel like there's too many things to remember when you do it. So I just do long division because that's stuck with me over the years. So remember to do long division. We're going to take a look at this lead term here and this lead term here and figure out what I have to multiply x by to get 3x squared. All right, and so that would be 3x. And now I'm going to multiply. Actually, let's do that in a different color so it makes sense. 3x. So now I'm going to multiply the green value, right, times the x minus 2 to the divisor and multiply that in. So I get 3x times x is 3x squared, and then 3x times negative 2 is negative 6x, and I'm aligning that right with its like term in the original. So I'm going to subtract now. So 3x squared minus 3x squared is 0, so those cancel out, and then 5x minus negative 6x gives me 11x here. And then I'm going to carry down the plus 2 and do my next check here. So now I'm going to check that x goes into 11x, and we know that I would have to do that 11 times in order to get that right. So now I'm going to multiply the green 11 times the outside x minus 2 to get 11x minus 22, and then subtract. That gives me 0, and then 2 minus negative 22 is 24. And that is obviously my remainder, right? So my remainder is up at the top. It's 24 over x minus 2 is how I would divide. This original integrand turns into the green integrand. So after the division happens, let's rewrite it as the integral of 3x plus 11 plus 24 over x minus 2. Okay, so it's hideous and it's ugly, but that's the truth. That's what it is. So now I'm going to integrate one term at a time, right? The integral of 3x is power rule, 3x squared over 2. Integral of 11 is 11x. And then the integral of the next part is, you know, kind of like a u sub because my denominator is a function, x minus 2, but hopefully we've done enough of these where we can go right to 24 ln absolute value of x minus 2 plus c. Okay, if you want to take the long way to that answer, you can. But since the coefficient of x is just 1, you can just go ahead and use the ln of that function and get away with it. Okay, so look at this ridiculous answer. Okay, it ain't pretty, but it's usually in the multiple choice part. So you can kind of, as long as you can do the division part, you'll probably be able to pick out the right answer from the choices that are there. Okay, after number 8, I want to go back now and do number 4. So let's go back to the front page. Because this is kind of a weird little division problem. Like, you can think of like x plus 5 and x minus 10, they're off, right? Because the top, right, they actually have the same degree here. So this is a very rare case where they have the same degree. And then that kind of clues you in, again, that you can't let u be the entire denominator like we did in a previous work with u subs, that you have to kind of do some dividing. Now, you know, the top is literally 10 more units than the bottom, right? The difference between 5 and negative 5 is 10 places. So when you divide these out, you're going to get 1 and a remainder of 10. But we'll go through what that looks like, I guess, just to justify. So x plus 5 divided by x minus 5, right, is just 1 because x goes into x one time. And then when I multiply 1 times the outside and subtract, x minus x is canceled, and then 5 minus negative 5 is 10, right? And that's my remainder. So I'm going to have 1 plus 10 over x minus 5. And I feel like this one is probably more in line with what you might see on the AP test, just because the division didn't take that long and it's not too rigorous. So remember that there's a moment where we're rewriting, right, the integral. I haven't actually integrated yet. And now my job is to go ahead and integrate. So the integral of 1 is x, and then the integral of the next chunk, right, this is 10 ln x minus 5 plus c. Okay. I want to clue you in. I want to skip to number 2 really quickly and kind of look at this one. Okay, and like let's look at the degrees here. Right? Since the denominator is a larger degree, this is actually not a division problem, right? And we're going to have to now be able to filter it. What style of integration am I using? So since it's not a division integrand, you're going to just go ahead and calculate the integral by other means. And the only other really thing that we have, since I can't just do a power rule to it, is to let u equal 4 minus x cubed. Our derivative is negative 3x squared, and then of course this part I'll keep, and then I'm going to divide by the negative 3 and get negative 1/3 integral. Let's see, this is 1 over u du, so this is negative 1/3 ln absolute value. Okay, and again, this part should totally, skip that. This part should be review for you. Okay, so that's my final answer there for number 2. So these problems are all going to be mixed in together, right, by the end of the year on the real test. So that's why we got to kind of practice. How do we filter them? The last one I'm going to do with you is number 3, and I'm actually going to turn number 3 into a definite integral because that's the type of question that you're going to see on Delta Math practice that goes along with this. So this is asking, not 6. We're going to integrate from 2 to 4. That's, I think, a better choice for this problem. And we're going to come up with a final answer that is a number because we have these limits. Okay, so pretend the 2 and the 4 were there originally. We see that the top degree, right, is a 2 and the bottom is a 1. So therefore, I know I'm probably going to have to use long division. So I'm going to set this up x squared minus 4x plus 4. Divide. I like to use all these colors because since I'm not there to point and explain to you, I feel like the colors might make it helpful. So when I figure out how many times x goes into x squared, that's going to be x times, and then I'm going to multiply orange times the green and write it underneath. So that's x times x is x squared, and then x times negative 1 is negative x, and then subtract. Those cancel. Negative 4 minus negative 1, x, right, is like negative 4 plus 1, of course, so that's negative 3x, and then carry down the plus 4. But then I'm going to go back and see how does this x, what does it take to go into the minus 3x, and that would be a negative 3 constant, because I don't need to change the degrees. Now the purple number times the green expression gives me negative 3x plus 3. And now when I subtract, let's see, these do cancel again, and 4 minus 3 is 1. So I have a remainder of 1 there. So it's going to be x minus 3 plus 1 over the green divisor, right, which was x minus 1. So first thing I'm going to do, is rewrite this. So I'm doing the integral from 2 to 4 of x minus 3 plus 1 over x minus 1. And then I'm going to integrate term by term. So first one is x squared over 2. The next one is just 3x. And then this guy is ln of absolute value of x minus 1. So that's the integrand. And then remember, I'm still figuring out what the value of that integral is from 2 to 4. So now I'm going to have to plug in all these numbers and see if I can get this right. So actually, let's make this top number green. So I'm going to plug in, that's not a 8. I'm going to plug in the 4 first. So this is 4 squared over 2 minus 3 times 4 plus ln of 4 minus 1. And then I'm going to subtract in parentheses, like I'm going to put that 2 everywhere, right? So 2 squared over 2 minus 3 times 2, and then plus ln of absolute value of 2 minus 1, close parentheses. So this gives me, I can simplify a little bit here, 16 over 2, this first term is 8, minus 12 plus ln of 3 minus in parentheses 4 over 2 is 2 minus 6 plus ln of 1, which is 0, so that part's irrelevant. So I've got negative 4 plus ln of 3 minus, and then 2 minus 6 is negative 4. Yay, that becomes addition. Negative 4 plus 4's cancel. And the final answer here is ln of 3. So if the long division blew your mind, please go back and watch maybe that Khan video. I think they're no more than 5 minutes. If you need a little help or, you know, a more slower explanation of how to long divide. Okay, and then the delta math, I think, is just like 6 questions long. So I think you can